Hello students, good morning. Myself Power MS from KJ Somaya College, Kopargaon. Today we are going to discuss our section CHO-150, that is a part of MSc first. In that section we have to discuss the rearrangement reaction. In previous lecture we have to discuss the benzylic acid rearrangement. In today's lecture we have to discuss the Sommelet-Hauser rearrangement. So this is your next rearrangement, Sommelet-Hauser rearrangement. We have to discuss here. Let us discussion about Sommelet rearrangement. So how or what is the rearrangement of Sommelet? So in this Sommelet rearrangement, ammonium quaternary salt, it is the important salt. This salt can be prepared and then 2,3 sigma topic rearrangement can be takes place and formation of the final product. So in this rearrangement, the ammonium quaternary salt can be obtained. This substrate is important. This substrate can be formed, then reaction can be followed by the final step, that is your final product. Okay, so we have to discuss here the theory of Sommelet rearrangement. First of all we have to take the, for example, see here, benzylic amine reacts with reacts with methyl iodide. So we have to form the ammonium quaternary salt. So we have to take methyl iodide in excess, then then formation of benzylic ammonium quaternary salt. This is your substrate of this reaction. So this quaternary ammonium salt reacts with base, and in next step pericyclic reaction takes place, that is a 2,3 sigmatropic rearrangement form, and we will get in final step by using by aromatization and form final product. So benzylic amine reacts with excess of methyl iodide, formation of the benzylic ammonium quaternary salt. This salt will be very important in this rearrangement, and then pericyclic reaction takes place, that is a 2,3 sigmatropic rearrangement takes place, and simple in final step aromatization takes place and formation your final product. So let us, we have to see here, discuss the mechanism of that rearrangement. So first of all, how the formation of ammonium quaternary salt in that reaction we will discuss. So first of all we have to take here benzylic amine. This is the benzylic carbon. So this is the structure of benzylic amine. So benzylic amine first of all reacts with the methyl iodide. So methyl iodide we have to take in excess. Why? Because of we have to form the substrate, that is a ammonium salt, which is formed by using the excess of methyl iodide in that reaction. So this nitrogen carries lone pair. So lone pair of nitrogen attack on this CME and depart this iodine. So in that reaction, this two hydrogen of nitrogen replaced by two methyl group. See here, we have to take here methyl iodide in excess. So these both two hydrogens of nitrogen replaced by the Me. This 2Me group we have to write in one step. Again we have to write this same way NHMe, and in next step again we have to use methyl iodide in excess, formation of this dimethyl amine. So in next step we have to use the again methyl iodide in excess. So lone pair of nitrogen, here again presence, formation of the salt, which is the important step of this rearrangement. Yummy, yummy. So this nitrogen carries positive charge. This is your substrate of this rearrangement. What is substrate? That is a benzylic ammonium quaternary salt. This is the substrate of this reaction. So again this substrate reacts with the base. So this substrate we have to write here N, yummy, yummy, yummy. So this is the ammonium salt. So this salt can be reacts with base. So what is the function of base? Base can be abstract the proton. So here presence of the proton from this CH2. So this base can be abstract this hydrogen. So formation of the negative charge over the carbon atom. See here benzene ring, nitrogen, yummy, yummy, and Me. This nitrogen carries positive charge, and here formation of the negative charge by using this base. In next step, this negative charge can stabilize by using the proton or hydrogen. So this Me we have to write in splitting, that is a CS3. So this negative charge can abstract this hydrogen. See here at that time this hydrogen shifts on this carbon. So this carbon carries negative charge. In next step we have to write here N, yummy, yummy, and here presence of the CH2, and this hydrogen used for the stabilization of negative charge over this carbon atom. So here there stabilization of negative charge, and here positive charge as it is. But this carbon carries again negative charge because of this hydrogen shifts on this carbon. So in next step, here formation of the negative charge. In next step, the main important step, that is a pericyclic reaction formation. So this is the 2,3 sigma tropic rearrangement takes place, and formation of your next intermediate. So how this 2,3 sigma tropic rearrangement possible? So see here this negative charge shifts on this benzene ring, or this negative charge attack on this carbon carbon double bond. At that time this bond shifts on this carbon, this double bond converted to single bond, and this single bond converted into the double bond. At that time this bond shifts on this nitrogen or break this carbon nitrogen bond, and at that time stabilize the positive charge over the nitrogen atom. In next step we will get this intermediate, that is a bond between this benzene ring and this CS2. Here this nitrogen Me as it is, this bond can be broken and stabilize the positive charge over the nitrogen atom. But here formation of the carbon carbon double bond, this double bond converted into the single bond, and here formation of the double bond. In next step, see here we have to use, or we will get here aromatization step, here aromatization takes place. Here presence of this hydrogen used for double bond formation. At that time, this bond shifts on this carbon, or this double bond converted into the single bond, or this carbon shifts on this carbon, formation of the negative charge. So in next step, formation of here CS2 negative charge, here formation of the carbon carbon double bond by using this hydrogen, the CS2 NMe as it is. So, but here formation of the negative charge we have to discuss in theory explanation. We have to use the base. So we have to take here for example HNS2. So negative charge abstract this hydrogen, and this bond can be breakum, formation of the NS2 minus. So here formation of the CS3. So in final step we will get CS3 CS2 N Ma and Ma. This is your final product. So this is related about the Sommelet rearrangement. How? First of all, see here again. Benzylic amine reacts with the methyl iodide. We have to take methyl iodide in excess. Why? Because of we have to find out, or we have to um, form the quaternary ammonium salt, that is a benzylic ammonium quaternary salt in excess. That's why we have to use methyl iodide in excess. So these salts can be reacts with again base, so formation of the negative charge, and in next step 2,3 sigmatopic rearrangement takes place and formation of this intermediate. Here simply bond formation with CS2 benzene ring, this double bond converted into the single bond, and here formation of the double bond. In final step simply aromatization takes place by using this benzene hydrogen, formation of the here double bond, but this carbon carries again negative charge because of this bond shifts on this carbon. So by using any base for stabilization of negative charge, or by abstract the proton, then formation of this your final product. This is your final product of Sommelet-Hauser rearrangement. So this rearrangement is finished here. So formation of this final product, see here. So this is all about the Sommelet rearrangement. So today we are going to stop here this rearrangement. Next rearrangement we have to discuss in our next lecture. Thank you very much.